So our next lesson is what we call factoring general trinomials. So this is going to be 13.3 out of the book. So factoring a trinomial can be done by many models, but the most part, notice how factoring is kind of this thinking backwards concept. One of the models I want to use is kind of back to that box method that we kind of did earlier, and also using what's called big T that we've talked about in identifying factors. So if I want to factor x squared plus 5x plus 5, remember, if I had something in factored form, say if I gave you x plus 5 times x plus 1, remember how we can also use the box method to kind of expand it out into expanded form. So notice how the x and the 5 could go here, and the x and 1 could go here. And then we multiply, we know that x times x is going to be x squared. X times 1 is going to be this 1x. 5 times x is going to be this 5x. And 5 times 1 is going to be 5. And therefore, the answer became then, notice how the 5x and the 1x were like terms. So this brought us down to then this x squared plus this 6x plus this 5. So what we want to do in factoring is one of the easiest methods is just focus on using what's called the box method. So notice though, in the box method though, in expanded form, notice how if it was already in a factored form, notice how the factors were on the outside edges. And what we did was found the inside. Now we're going to be given the inside, and we want to factor out what's on the outside. So notice how the x squared, the quadratic term, what's going to happen is it's going to be in the top left corner of the box. So the x squared is going to go here. What we also pick up on is the 5. The 5 is going to be the bottom right. But the catch is, notice how the 6x is broken apart into these two boxes. So where does the 6x come from, though? Notice essentially what it is, it's actually just the factors of the 5. So if I use big T, notice that the factors of 5 have to add to a 6. So there's two puzzles we have to look for. Well, there's only one pair of factors of 5, which is the 1 and the 5. Notice how 1 times 5 does give you this 5, and 1 plus 5 does give you the 6. It has to kind of pass both of those tests. If it does, then these become the linear coefficients. So this becomes in this 1x and this 5x. So what happens is we build the inside first. And then once we build the inside, we start to look at the outside. And one way of doing this is if you look across here, this x squared plus this 1x, what we want to do is identify its GCF, which would only be, the only thing they would have in common would be an x. So an x would come out. If you look at the denominator, notice that the only common factor between a 5x, I'm sorry, look at the bottom row, I should say. Look at this bottom row. Notice how there's a 5x and there's a 5. Notice that what the only thing they have in common is actually 5. So I can actually just pull that out. So you can kind of see that. The other thing is, remember, this here has to multiply across to get the top edges. So notice how x times x gives you x squared. X times x gives you x squared. And then here, I would need a 1 times x to get 1x. Notice how, again, if we look at this bottom, does 5 times x give you this 5x? And does this 5 times 1 give you this 5? So what we did is we matched the inside and the outside together. But the outside becomes what we call the factored form. So this becomes then this x plus 5 times x plus 1. That becomes our strategy in factoring, putting it back into a factored form. So if I want to factor x squared plus 4x minus 12, notice how it's not a difference in squares. It's not two terms, so I can't use a special product. And notice how the negative 12 is not a perfect square either. There's nothing you can square that's going to give you a negative 12. So this becomes, it kind of falls apart. So this becomes what we call a general trinomial. To factor a general trinomial, one way of doing it is using just the box. So when we factor the box, using the box, what happens is we start with the inside. So the x squared, the quadratic term, goes in the top left. The constant, which is the negative 12, goes in the bottom right. That's our first move. But then what we focus on are the factors of the negative 12. And what we want to do is figure out what are the factors of this negative 12 that add up to give me the middle term, which is at 4, the coefficient of the middle term, or the linear term. So if we look at the factors of 12, we would have a 1 and a 12, a 2 and a 6, a 3 and a 4 and a 3. That's repeating. So we're looking for which one of those pairs of factors could give me a negative 12 and also a positive 4. Well, the first thing to pick up on is to get a negative 12, one has to be positive, one has to be negative. But remember, to add and get a positive number, that means the smaller number has to be negative. So that means that this side over here has to all be negative. So now I got the negative 1 times the 12 and the negative 2 times the 6 and the negative 3 times the 4. They all give me a negative 12. But which pair of factors actually gives me that positive 4? And what we pick up on is this negative 6, this negative 2 and the 6 actually would work. So what happens then is those become the coefficients of my linear term. In other words, they fill the rest of the box in. So I put a negative 2x here and a 6x here. And again, it doesn't matter which way you put those. Now, an easier way to do this is to simply focus on what would these two edges have to be to get an x squared. Well, there's only one choice, and that's x times x. And then notice that x times negative 2 would give me a negative 2x. And then down here, what times x gives me 6x. That would have to be a 6. And then 6 times negative 2 does give me a negative 12. So I have completed the factorization. And remember that the factorization is the outside edges, which is the x plus 6 times the x minus 2. And again, order does not matter. If you had x minus 2 times x plus 6, that would still be correct. So notice you also could use the GCF concept. What does an x squared and a negative 2x have in common? They would both have an x in common. What does a 6x and a negative 12 have in common? That would be a 6. So we are still kind of using GCF strategies, but we don't necessarily have to think that hard if we don't want to. It's also a puzzle that if we can match the pieces of the puzzle, we can kind of put it all together that way. So if we look at this next example, x squared minus 20 minus x, notice how it really has to be rewritten in the correct order. Remember, it's got to go in descending order. So x squared minus x minus 20 would be the correct way of writing that. So again, if I want to factor this, one way of doing it is using what I call the box method. Because notice how, again, the negative 20 is not going to be a perfect square. So this is going to be called a general trinomial. It doesn't work. So using the box method as a strategy, what we pick up on is the quadratic term goes in the top left. The constant is the negative 20. It goes in the bottom right. And also what we can do is we have to figure out what are the factors of this negative 20 using big T that are going to add up to give me the coefficient of the linear term. Now remember that coefficient was actually a negative 1. So really what we're looking for is this negative 1. So the factors of a negative 20, again, just focusing on the 20, we'd have a 1 and a 20 to start with, a 2 and a 10, 3 doesn't work, 4 and 5 does work, 5 and 4. So that's my mental thinking. Most common time with this factoring, it's usually the most common ways of getting a number. When I think of getting a 20, I would either be thinking 2 and 10 or 4 and 5 before I'd go to the 1 and 20. So typically it works that way. And notice how the 4 and 5 look really good as long as I make one of those negative. And notice how the 5 would have to be a negative here. 4 times negative 5 does give me a negative 20, and 4 and a negative 5 does give me a negative 1. So that's going to complete the inside. I actually like to keep the negative up here on this top right. I like to keep the negative out of this bottom left position. It doesn't really matter, but it does make the math sometimes easier if I don't have to deal with that negative out in front. So again, if I look at the GCF of these two terms, we kind of see that there's an x in common. Or again, x times x does give me x squared. So this has got to match. X times what gives me this negative 5x. I need a negative 5 up here to get that edge to work. And then I'm working on this bottom row. I would need a 4 here because, again, 4 times x does give me 4x. And also that 4 times negative 5 does give me this negative 20. So this strategy does get it all organized for me. And then I can just write the factorization in of x plus 4 times this x minus 5 as my factorization. So another strategy is when we have 4 terms, is there's this thing called grouping. So grouping basically, for the most part, it's grouping like the first 2 and the second 2. So usually what I do is I'll draw a box around the first 2, and I'll draw a box around the second 2 like that. So when there's 4 terms, grouping is usually the first strategy. So once I group, the next strategy is to find the GCF of each grouping. So if I look at the mx and the 2m, notice how they would have an m in common. So I factor an m out, and that will leave me then with this x plus 2. And then in this next position, notice how we have a negative out in front. So remember, if the leading coefficient is negative here, we want to pull that out as well. So what I want to do is look for the negative, and also notice how the 4 and the 8 have a common factor of 4 in them. So what we want to do is we want to actually pull out a negative 4 as a common factor. In doing so, that's going to just leave me an x. And remember, when you factor out the negative, the sign's got to change here. So it's actually going to turn into a positive for that second part. So now that's in that position. And also earlier we mentioned that if you have a common binomial factor, we can also pull that out as a GCF. So now we actually look at that common binomial factor. So that common binomial factor now comes out. So that x plus 2 comes out, and that just leaves me then the n minus 4 as my remaining piece. And that's now what we call a factored form. So if I expand that back out, it should give me the mx plus the 2m minus the 4x minus the 8. So if I look at this next example, if I want to factor that, since it's got 4 terms, what we can do is use what's called grouping. So if I group the first 2, and if I group the second 2 together, that's my first move, is group. My next move is then to identify the GCF of each pair of groupings here. So between the y squared plus the 2xy, notice how they do have a y in common. So when I divide that y out, that leaves me a y. If I divide that y out there, that leaves me a 2x. So I'm left with y plus 2x. If I look at that second grouping, notice how they do have a 3 in common. So I'm going to factor out a positive 3, so I put a plus 3 out there. And then when I factor that 3 out, that leaves me just the y. And when I factor that 3 out of the 6, in other words, I'm dividing the 6 by the 3, that leaves me that 2x. Notice how, again, though, there's this common binomial factor. Since they have this common binomial factor, what I want to do is factor that out. That's going to give me this y plus 2x on the outside. And then the remaining 2 factors are that y and 3, and we put them in parentheses as well as our second grouping. So we have that as our factorization. And now that's what we call factored form, because we have a binomial times a binomial. So that's considered our factored form. So if I have 6x squared plus 19x plus 10, if I want to factor this by grouping, I can. Now, the way I want to do this grouping, though, is I want to use the box method. Now, remember, though, in factoring, some things you want to look for is there a GCF to start with? You know, if I look at these 3 terms, does 6x squared, does 19x, does 10, are there any common factors? Well, that 19 kind of kills it all. So there's not a GCF. The next thing we're supposed to be looking at is this a difference of squares? Well, it's not 2 terms, so it's not a difference of squares. The third thing we're supposed to be looking at is this a perfect square trinomial? Well, the first term's not a perfect square, nor is the last term a perfect square, so that crashes. So this becomes what we call factoring a general trinomial. A general trinomial, what we like to do is I like to just use the box method as a strategy, because this helps me do my grouping for me. So remember, when I use the box method for a general trinomial, the quadratic term, the 6x squared, will go on the top left. The bottom right is the constant, which is the 10. Now the catch is when I make big T, since now the quadratic term has a coefficient that's not 1, our strategy for big T is actually multiply the 6 and the 10 together to create our big T. So the 6 and the 10 get multiplied together in forming big T. So 6 times 10 becomes then the 60. So what we have is a 60, but we have to add to get the middle term, which is going to be this 19. So we're looking for the factors of the 60 that give me this 19. So again, you can be using a calculator here. I'm not going to reach for my calculator. I'm going to kind of keep my screen clean. So I do know that 1 and 60 are factors of 60, 2 and 30, 3 and 10. So far, so good. 4, I don't know. So what is it? 4 times 15, maybe? Yeah, 4 times 15 does give me 60. So 4 and 15, 5 and 12, 6 and 10, 7, no, 8, no, 9, no, 10 and 6. That's just repeating. So that would be my different factor pairs. So what I'm looking for is one of those factor pairs that multiplies to give me that 60, but it has to add up to that 19. And notice how 60 is a positive number, so both signs can be the same. And we do see that this 4 and this 15 match up with 60, and 15 plus 4 does give me this 19. So what happens is they become my linear coefficients. So inside here, this becomes a 4x, and this becomes a 15x. So from here, we look across here and we identify the GCF between a 6x squared and a 4x. So the GCF between a 6 and a 4 would be what? A 2, and they both have an x in common. So I would pull out that 2x. So if I use division, or kind of take it out, if you will, this remains with a 3x, because again, with division, I kind of use multiplication anyway. Does 3x times 2x give me 6x squared? Yeah. So 2x times what gives me 4x? Well, that'd have to be a 2. 2x times 2 does give me 4x. If I look on the bottom here, what times 3x gives me 15x? I pick up on a 5 there. And does that 5 times 2 give me this 10? Yeah. So what I can do is use that kind of grouping using the box method as a strategy. That gives me 2x plus 5 times the quantity, 3x plus 2 as my factorization. Lost something there. Get back up here. So let's look at 20x squared minus 23x plus 6. So again, if we follow what we've done, we should be looking for a GCF to start with. Is there a common factor between these three terms? Notice how we kind of fall apart with that 23 in the middle, that we don't have a common factor there. To be a difference of squares, we have to have two terms. To be a perfect square trinomial, the first term and the last term have to be perfect squares. Neither one of those are perfect squares. So this leads us to doing a general trinomial concept. Now, since the quadratic term has a coefficient that's a 20, we have a little bit extra work to do. So when I draw my box as an organizer, a grouping way, my quadratic term is the 20x squared. It's going to go on the top left. My constant is a 6. It goes to the bottom right. Now, to build the middle term, we have some work to do. So this is where big T comes into play. So if I multiply the 20 times the 6, that's going to give us then our big T. So 20 times 6 is going to be this 120. So we need to find the factors of 120 that give me a 6. So notice that the factors have to be kind of close together, So if you think of 20, can you think of some common numbers that would give you 20? Well, if not, let's just go down the list. We have 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and, I'm not sure about 5 and 120. We went to 10, 20, 24. So 5 and 24, 6 and 20, 7 and 8 and what? I think 8 would probably work. 8 and 120. So like what, 1 be 15. 8 and 15 would be good. 9 I don't see happening. 10 and 12. 11 no. 12 and 10. would be it. So what I'm looking for are the factors of a 20, but what I got to add up to actually is I don't know why I put that 6 there. My middle term is a negative 23. So back up on that. Why did I put a 6 there? I don't really remember. But it should be the middle term, which is a negative 23. So notice that to get a negative 23, both signs actually have to be negative. This has to be a negative, and this has to be a negative down through here. So both have to be negative. And remember, in adding negative plus negative, you just add and keep the sign. So it's still an addition problem in that sense. So if we look through there, which one of those gives me this negative 23? Looks like it's got to be down here somewhere. Yeah, this looks like it right there. So that negative 8 and a negative 15 would be a negative 23. And we do know that a negative times negative is a positive 120. So that becomes my coefficients of my linear term. So this becomes then a negative 8x and a negative 15x. So I couldn't avoid the negative there in both spots, but that's no big deal. So let's go ahead and find the GCF of the top row. Between a 20 and an 8, I'm picking up on a 4, and there's also an x in common. So I'm picking up on a 4x. So then if I kind of come up here to the top, instead of using division, I kind of think the other way. What times 4x is 20x? We would have a 5x. And so instead of dividing here, I can actually just say what times 4x is negative 8x, and that would be a negative 2. Negative 2 times 4x is negative 8x. Or again, you can use division if you wanted to. You could be going negative 8x divided by 4x, if you will. Notice how the x's divide out. Negative 8 divided by 4 would give you negative 2. So you can actually be using division, or like I said, most of the time with me, division really is a multiplication concept when it comes to long division kind of things. So again, what I'm trying to figure out now is what goes here. What times 5x gives me negative 15x? That feels like a 3. And does 3 times negative 2 give me this 6? No. So I'm kind of wrong there. 3x times 5x is not negative 15x. So I need a negative actually there, don't I? Does a negative 3 times a 5x give me negative 15x? Yeah. Does negative 3 times negative 2 give me a 6? That now checks out. So I kind of do it both ways. So the outer edges are my factorization. So this becomes then 4x minus 3 times the quantity 5x minus 2 would be our factorization. And that's what I mean by factoring by grouping, is do it that way. So let's look at these next examples and see if we can factor these examples completely. So again, as we look across here, 4x cubed minus 2x squared minus 6x, it's kind of crazy, but notice how, to start with though, I'm gonna go ahead and just rewrite the problem. So mentally, if you will, I'm kind of feeling this GCF going on. Notice how this 4 is 2 times 2 times this x times x times x, if you will. And then I have like minus this 2 times x minus this 2 times 3 times x. That's kind of my middle step. So what I'm trying to figure out is, what is my common factor? So notice how they do have a 2 in common, and they also have an x in common. So my GCF is actually a 2x. So I bring that out, and then the remaining factors are the 2x times x, which is x squared, minus then this x, and then minus this 3. It turns into that. So I have a 2x coming up, but notice how this 2x squared minus x minus 3, is that prime or is it factorable? Well, it's not a difference in squares. It's not a perfect square trinomial, but it is a general trinomial. So what we want to do is we want to factor this this 2x times this x squared minus x. So I'm going to draw my box down here a little bit lower so it's not in the way of my problem. So remember, when I do it this way, the quadratic term, again, I'm focusing on just this part right here. The 2x squared goes in the top left. The negative 3 goes on the bottom right. Since there's a coefficient in front of the x squared, we have to use big T, but remember, we got to multiply the 2 times negative 3 together to get this big T. So when I use big T, 2 times -3 is actually -6. And I got to end up with the coefficient of the linear term, which is a -1. So we want to find the factors of a -6 that add up to a -1. So we have a 1 and a 6, a 2 and a 3, a 3 and a 2. So really, it looks like we're down to these two pairs. Now, to get a -6, but add to get a -1, that's our catch. So notice how we do need a -3 there. So notice how 2 times -3 does give me -6, and 2 plus -3 does give me a -1. So that kind of matches that. So the 2 and -3 become my coefficients of my linear terms. This becomes a 2x, this becomes -3x. So again, our strategy is to pull out the GCF. And typically all you gotta do is pull out the GCF on the first row. So if I look at the 2x squared and the 2x, notice how they do have a 2 and an x in common. So then if I use my thinking, instead of using division, what times 2x is 2x squared? Looks like I'm missing an x. X times 2x is 2x squared. You know, up here, what times 2x is 2x? Well, I would need a 1 there, okay? And then we're down at this spot. You know, what times x is -3x? You have to watch out that that's actually going to be a -3. So -3 times x is -3x. And does -3 times a 1 give me -3? Yeah. So what happens is when I factor this, the 2x is going to come down as my first piece. And then since 2x squared minus x minus 3 is factorable, we write it in its factored form, which is 2x minus 3 times then this x plus 1, and that becomes its factorization. So it becomes those three factors, if you will. So 12x squared minus 27, what's the GCF between a 12x squared and a minus 27? Well, if you think the greatest common divisor, again, if I don't want to do this breaking it all down, can you see the GCF between a 12 and a 27? Because they don't have any x's in common. If you can't see it, you could use a prime factorization for that again. You know, the factors of 12 would be 2 and 6 and 2 and 3 and 2 and 1. The factors of a 27, if you will, leave out the negative to start with. You know, 2 doesn't work, but 3 goes into 27 9 times, 3 goes into 9 3 times, and 3 goes into 3 1 time. So what do they have in common? Looks like I did something wrong. 2 went into 6. Just try that 12 again. I don't think that looks right. Something didn't come down correctly. Talked too fast. So 2 does go into 6. 2 does go into 12 6 times. 2 does go into 6 3 times, but 3 goes to 3 1 time. So notice how the only thing that they have in common really is a 3. So 3 becomes the GCF. So what I'm doing is pulling out a 3 or dividing a 3 out. So remember, you can write what's left, which is the 2 times the 4. So again, a 3 is coming out. For the 12, we're left with the 2 times the 2, which is a 4. That's going to be 4x squared minus then, since the 3 came out, that left us with the 3 times 3, which is a 9. So we had this 4x squared minus 9. So now we want to try to factor this. You know, 3 is a GCF, but notice how we have this 4x squared minus 9. What we're trying to do is figure out if that's prime or is it factorable. Well, since it's two terms, it has a subtraction symbol. Is that a difference in squares? Well, if I think about that, I'll come down here out of the way. You know, 2x squared does give me 4x squared. 3 squared does give me this 9, and it is a difference. So this tells me that this 4x squared minus 9 is actually factorable. So it's going to be 2x minus 3 times the quantity, 2x plus 3. It's going to be that conjugate math where one of them is minus and one of them is plus. So lastly, we have this negative 18x cubed plus this 24x squared minus this 8x. So our first objective is, can we identify a GCF? So one of the things we don't want is that negative. So negative is going to come out to start with. But what about that 18, that 24, and that 8? If we just ignore all the negativity and just focus on the numbers themselves. So can you see the greatest common divisor, or in other words, what's called the greatest common factor of those three? If you can't, we can just kind of do this 18. Let's see here. We've got something going on here. Let's get that out of the way. So this 18, this 24, and this 8. if I look at the 8, 8 does go into 24, but 8 does not go into 18. So 8's not. But what's the next biggest factor of 8? Well, that'd be a 4. Well, 4 goes into 24, but 4 does not go in 18. So we have to drop down again and put. But notice how 2 is a common factor of all those. So what I'm kind of picking up on is this 2. So notice how we can actually focus on the smallest one, identify its factors, and see if they actually are factors of the other 2. So I kind of pick up on that the 2 is. Or again, we can use what's called the prime factorization. 2 goes into 18 9 times, 3 goes into 9 3 times, 3 goes to 3 1 time. 2 goes into 24 12, 2 goes into 12 6, 2 goes into 6 3, 3 goes into 3 1, and then 2 goes into 8 4 times, 2 goes into 4 twice. Or I'm sorry, kind of got ahead of myself on that one too, didn't I? Get that up a little bit. So 2 went into 4 twice, and 2 went into 2 one time. So that's how they do have a 2 in common. But that's it. They don't have anything else because the 18 is what's killing us, is because all that's left there is 3s and no more 2s. So looking at C, I have this negative 18x cubed plus this 24x squared minus this 8x. What I want to do is pull out the negative and the 2. So I'm going to pull that out. In doing so, this is going to leave this to be a 9. We also have an x in common, I should say. Don't forget about that. So negative 2 and an x are in common. So if I do that, that's going to turn that into a 9x squared. And then remember, the signs are going to all change. This is going to be a minus 12x. And then if I take that out, remember the sign's got to change to a plus, and that's going to be a plus 4. So we have negative 2x, and then we have this 9x squared minus this 12x plus 4. So if I want to factor this, again, the question is 9x squared minus 12x plus 4, is that prime or is it factorable? Well, it's not a difference of squares, but the question is it a perfect square trinomial? Well, 3x squared does give me 9x squared. 2 squared does give me 4. It passes those first 2 tests. Now, if you multiply these 2 together and double it, 2 times 3x is 6x. And if you double that, in other words, add it twice or multiply by 2, we do get this 12x. So that's how we do match that middle term of that negative 12x. So that means this last term actually had to be a negative. So we pick up on that this is factorable. Negative 2x times the quantity 3x minus 2 squared becomes its factorization of that polynomial. So that's called what we call factored form. All righty, that takes us to some factoring of some general trinomials with a little extra there.